Today's lesson is about interior and exterior angles, and we're going to start with a whole list of facts and formulas, and then we're going to be applying them. To begin, the sum of the interior angles, so the inside angles, of a convex polygon can be found using the formula n minus 2 times 180 degrees, where n is equal to the number of sides. The measure of each interior angle of a regular convex polygon can be found using the formula n minus 2 times 180 degrees, all divided by n. The sum of the exterior angles of a convex polygon is 360 degrees. Now you get one exterior angle from each vertex. The measure of each exterior angle of a regular convex polygon can be found using the formula 360 degrees divided by n. Now, keep your list of formulas in front of you, that first page, and let's see how we can apply some of this information. Now, you're asked in the first problem, find the sum of the interior angles of a 15-gon, so a 15-sided polygon. Well, the formula for the sum of the interior angles of a polygon of n sides is n minus 2 times 180 degrees. So in this case, n is 15. Let's plug 15 in place of n, so we have 15 minus 2 times 180, or in other words, 13 times 180 degrees. And what do we get? We get 2,340 degrees. Let's look at number 2. Find the measure of each exterior angle of a nonagon. Well, first of all, I'd like to add the words regular nonagon. All right, so we know that each interior angle is the same. So the measure of each exterior angle of a nonagon is equal to 360 degrees divided by n, where n is our number of sides. So we're going to take, in this case, 360. How many sides are in a nonagon? Well, n is 9. That's also the number of exterior angles. So 360 degrees divided by 9 is 40 degrees. So each exterior angle measures 40 degrees. Next, we're given this figure, and we're asked to find x. Well, first of all, let's determine how many sides there are in this figure. It looks like n is 6, the number of sides. Now, our formula, n minus 2 times 180 degrees, tells us what the sum of the interior angles of a convex polygon would be with n sides. So let's see what all of these angles should add up to. Let's plug 6 in place of n. So we have 6 minus 2 times 180, or in other words, 4 times 180. And we get 720 degrees. It's what all of those angles should add up to, including the missing angle. So let's add up the angles that we know: 136, 105, 136, 142, and 88. If we add all those angles together, we get 607 degrees. So the angles that we know add up to 607 degrees. We need all the angles to add up to 720. So if we take 720 minus 607, we get our missing angle of 113 degrees. Let's move on to our next page. The measure of each exterior angle of a regular polygon is 45 degrees. How many sides does the polygon have? Well, let's think about it. 360 degrees divided by n, the number of sides, will give us the measure of each exterior angle. Well, we know that each exterior angle in this case is 45 degrees. So basically what we have is an equation where we'd like to solve for n. Now what we can do is put the 45 degrees over a 1 and cross multiply. So 45 times n is 45n, and 360 times 1 is 360. We get n alone by dividing each side by 45, and n equals 8. So 8 is our number of sides. Next, the measure of each interior angle of a regular polygon is 160 degrees. How many sides does the polygon have? Well, let's think about the formulas that you were given at the beginning. The formula for the measure of each interior angle of a regular convex polygon is given by the formula n minus 2 times 180 degrees divided by n. Now that's the measure for each interior angle. Now we're told that each interior angle equals 160 degrees, so we can just plug in our 160. So what we need to do is solve for n. Now, what would probably make sense is to start by putting a 1 under the 160, and then we're going to simplify. Let's simplify these parentheses a little bit, and then we'll cross multiply. So 180 times n is 180n. 180 times negative 2 is negative 360. So I have 180n minus 360 equals 160 over 1. I had put the 1 there so we could cross multiply. So let's go ahead and do that. We cross multiply. We end up with 180n minus 360 equals 160n. Now, we want to get n alone, so we need to get all the n's on the same side. So let's subtract 180 from each side, or 180n. And we have negative 360 equals, and I just wrote down the same thing, didn't I? Let's see, let me rewrite that, equals negative 20n. Now, we want to divide each side by negative 20, so we can get n alone, so the negative 20s cancel, and we have n equals 18. So this particular polygon has 18 sides. You're probably thinking that you're glad I haven't asked you to draw that. So no, we're not going to try to draw anything that large. So let's move on to the next question. If this pattern were to continue in this picture, how many sides would the polygon have? You might be thinking, well, how would we do that? Well, let's think about this just a little bit. If we were to continue the sides of this polygon, and I'm not drawing this terribly well, but you get the idea. I could look at the exterior angles of the polygon. Now I know that each exterior angle along with its interior angle adds up to 180 degrees. So this exterior angle is 60, this one's 30, this one's 60, this one's 30, and so on around the polygon. Now let's think about it. what do all of the exterior angles of any polygon add up to? Well, all the exterior angles always add up to 360. All right, so they add up to 360 degrees. So think about how we would continue this pattern so that all of the exterior angles would add up to 360. Now, I want you to just think about this, and this is how we're going to start our next class. I'd like you to just think about how we would figure out how many more exterior angles we would need to make this add up to 360. And this is how we're going to start our next class, is answering this question. Thank you very much for joining me.